This is a demonstration video for the developed work by the Portuguese Consortium composed by Instituto de Telecomunicações, IT, of Aveiro and Wavecom. The Portuguese contribution to 5G Perfecta was developed with two scenarios in consideration of video broadband and vehicle driving assistance. Regarding the first scenario of video broadband, here, clients on a vehicle request a video transmission from a remote video server outside the 5G network context. In order to perform this test, Wavecom developed a CPE able to provide clients with a connection to the 5G network as it is represented in the picture on the right side of the screen. This device is then located at the moving vehicle, bridging video clients on client machines to the CPE with the on-site eNote B to which the CPE connects. Advancing to the next scenario, clients are now requesting a video that is being served on a machine also connected to the 5G network context and within the moving vehicle, as you can see in both figures below. A video is being transmitted in the second Wavecom CPE placed in the black Volkswagen vehicle, while its connection to the eNote B provides a client within the other vehicle to receive the transmission in a similar manner to the latter test procedure. These tests were executed in Aveiro, more precisely at Cais da Fonte Nova, where in a circuit we've made, we got to a maximum distance to the eNote B of 500 meters, where line of sight to the antennas was, half of the time, available. With video transmissions of 1 minute each, we performed several trials varying the amount of parallel traffic during these transmissions, in order to retrieve data on how these factors interfere with the video reception in each test. As we used the transport and application of MPEG-, set of streams were available with different resolutions and bitrates, being the maximum of these 4K with approximately 34 megabits per second. In these tests, we also performed the set with 4G technology in order to further compare the results between both cases, hence the saturation levels have values with two different bandwidths, where in each case the left value was the amount applied in 4G and the right one to the 5G tests. In this first scenario, we can see the CPE position inside the car with which we will provide a network connection to a client within the vehicle, allowing it to receive video from a remote server. In this video, we can see the distance and positions of both CPE and eNote B as we follow the circuit that we have mentioned before. In the second scenario, again in the same circuit, a Wavecom CPE is positioned in this car being a video server connected to the 5G network and to which the client, positioned in this Fiat vehicle, will try to watch the contents through a second CPE, which is also retrieving as metrics for the transmissions. A client, on a different machine, is connected to the CPE watching the video play, while a connection to the 5G network is in course, where packets are requesting for specific contents with a given quality to our MPEG- server positioned in the CPE on the Volkswagen vehicle. Notice that the server vehicle is moving randomly within the designated circuit that we have mentioned before. Now, on the corner of the screen, we can see the visualization that is in place in the client's machine, where one can see the video varying its resolution according to what MPEG-his client thinks best for the user experience not to be affected by decoding and transmission error artifacts. As this transmission is not only affected by our connection to the eNote B on the client vehicle, the connection is also affected on the server side, but, as we can see, the proximity of vehicles does not interfere with the video transmission. Regarding an analysis, here are the results of our first scenario, where we had a first batch of tests where no iPerf was in execution, and then two batches where iPerf granted us, with traffic coming from the server to the client with 125 and 250 megabits per second respectively. With this in mind, one can verify that the video quality level changes drastically throughout the amount of data being transmitted in parallel. and that this is relatable with the metrics from layers below, such as the network delay or even the SINR RSRQ. In fact, as one can see by the cumulative value of received bytes in dark red, in 5G, regardless of the saturation level, the rate to which bytes are received is very consistent throughout the cases. In the next vehicle-to-vehicle scenario, this rate is not so consistent, but it still regards some of those characteristics, since now we also have to measure the status of the link and the processing of the server node, which is also using other 5G link. Still, one can see a drop in quality levels as expected by the latter results and higher levels of video delay, since the connection to the video server is now subject to two 5G links of connection.